Hello, I am François Bouteille and I will carry on the presentation of air profile training courses for compressed air. We have seen point one, which was the traditional course plan, and this is a course plan which has a lot of interest and may be needed for engineers, for example. Sometimes, however, we believe that people cannot stay 3 or 4 days learning, and some more detailed trainings, more concrete things, and not less theoretical, but other things might be very useful for operators especially. So we shall present today training for compressed air based on analysis of need. So the way to show this kind of training, which is, in my opinion, essentially interesting for operators, people who run the compressors and the pipework. The way of showing this training is starting the training. I don't believe that we can say more abstract things about respecting the need, nothing more than the needs. This is something that we show by doing it. So we shall start the first training today with a simple operation, a very simple schema. So this is something where I have a doubt, because many words in English are very close to French, and when they are the same, usually they have different meanings. So it's a pity for the French. Schema might mean diagrams, and we believe that it is very important to draw the diagrams representing your compressed air station and the pipe work, and to think about it. Measurements, measures. What we mean actually is measurement results. Values, measured values, and possibilities of recording them for future use. So it's interesting to explain that we have put these two aspects, diagrams and measurements, in the core of our methodology of audit, because we have discovered something. The first thing that we have discovered is that many people draw a diagram representing the compressed air station which they have measured and which they study. And in the report, it is funny, but very few engineers in France that I know say or write anything at all about the diagrams which they have sometimes very precisely represented. Well, very often they take a copy, of some work which has been done by operators, and some good engineer which I know in EDF, Electricité de France, said to me that, okay, he said nothing about the diagram that he had presented, but it's useful because when he takes the report 5 years later, because he may turn back to this plant five years later, he will remember the ideas that he had, and he will get into a new audit of the plant more easily, because he will find back things which he had taken time to put drawing on the computer in a diagram. So my first conclusion was that as our competitors present diagrams but say nothing about the diagrams, we would say something about the diagrams, And so I said, okay, now when we put a diagram, normally we do, we have to comment it, give an analysis of a diagram. How is the pipe work? Is it decent? Is it rational? Is it fit to the need? And then a second experience was about measurement. This is the most frequent activity in my company. We have bought 5 or 6 ultrasonic floaters for compressor, very expensive machines, you know, instruments, and we make measurements every week in 2 or 3 factories in France. We have also 15 power analyzers. We have a quantity of measurement results, which is something very heavy. And personally, you know, very often I have to discipline myself to simply take the time of examining and looking at the measurement curves, you know, at the curves that we put on Excel. We have to analyze this a bit, you know, spend some time, not just take the average value and say, okay, your power station, your compressor station has got this ratio, this indicator, which is kilowatt hour for each cubic meter produced. So I said we have to, if we have a lot of measurements, we have to take time to look at the measurements and discover maybe some events, something which was not looked for, you know. And one of the last studies that we have realized 35 measurements of electrical power of compressor flow in a PET plant, blowing bottles of plastics, you know, for water, for mineral water. The goal of the measurements was to check that some new molds would actually help saving 20–25% about of energy, which is a lot, you know. And when I looked very attentively to the measurements result, I discovered that a very classical mistake or dysfunction in the blower, in one of the blowers, resulted in 290% extra cost, you know, compared to what was normally the cost of operation. The thing there was a big leak inside the blower, 2 leaks, you know, 2 of the heads were seemingly leaking. And when you put 25 bar air in the leak, you know, it's a lot of air. So the goal of my study appeared to be like a small variation on top of a big tsunami, you know. It was a big event, and I was very happy to have seen it because I spent time looking at the results. So what would I say about a schema, a diagram that would be useful to study? I will put a very simple and incomplete diagram. Here I will imagine in my future installation, you know, the one we use for the training, I will use only 6 information. 6 pieces of information. We shall start by the information on the top, which should be compressed air usages. What do the people do with compressed air? So in this case, I have chosen bag filters. 1 bag filter or many bag filters, I don't know, bag filters. Yeah? So this will be the case in many plants like cement plants or paper plants where you have transportation of powder by means of compressed air. So you need bag filters. It might be also agroalimentary plants. The second thing is cylinders, pneumatic cylinders. The third will be regulating valves. Of course, in a real plant you have much more final usages of compressed air. But this one is important because it needs some pressure, not too much pressure. Usually it's about 5 bar gauge. Cylinders will like to have a bit more pressure. Very often cylinders will like to work at 6 bar gauge. And here, regulating valves do not need much pressure usually, because they use a 1.5 bar gauge compressed air. So they are different for the need concerning compressed air pressure. They are very different. And the three usages are very different for a second criterion. So the first was pressure. Pressure is something very important in compressed air. It's the difference between compressed air and air which is not compressed. The second criterion will be water hygrometry. Bag filters will have problems if it's a cement plant and if they get liquid water on the bags. Well, then the bags will be destroyed very quickly, because they will be tapped by cement. Cement and water make what we call béton in French. It becomes hard, and then it cannot be cleaned. You will have to change your bags, which are very expensive, very often. Water in cylinders will cause a slow function of cylinders, because the distributors will not work very fast and can even be blocked if they are full of liquid water, because water is not compressible. So it will be, sometimes your machines will have, in the manufacturing industry, for example, you may have small losses of productivity because the cylinder stops. And regulating valves do want very clean air, no liquid water. So I have three interesting usages. They show already the diversity of needs of final usages of compressed air. And here I will take screw compressor, and probably a lubricated screw. This is not very important here. Lubricated screw, so compressed air with oil, because none of these usages suggest that we should be very cautious and take an oil-free compressor. It's not. These compressors are very cheap. You have a lot of people producing them, so it might be sufficient. And then you have here a certain quantity of unknown, 2 or 3 zones which are unknown. What about dryers? Nothing is said. We don't say nothing here. Pipework. Here on this first level, a very simple diagram, we say nothing about pipework, and we say nothing about measurement, about plan de comptage, counters, about energy management and measurements. What we know is that you have air going somehow from one zone to the final usages. And what we shall see in the next step of our presentation is that even a very small, very simple diagram allows you to prepare something very interesting as measurements, and you can, with some means, have interesting results. So rendezvous, we meet at the next presentation. Thank you.